Hello, I am HampsonRussell, the Senior Technical Advisor working for CGGeo Software. I would like to demonstrate few functionalities of Advanced 3D Visualization module of HampsonRussell. I will display visualizing the 3D volumes, wells and horizons, how it is done, capturing geobodies, which is coming from the LithoSI, phases and fluid analysis modules, red, green, and blue and alpha blending of the 3D volumes could be from spectral decomposition, could be from inversion results, visualizing geostatistical inversion results coming from the GeoSI, and visualizing fractures and fracture uncertainty, which is coming from ProAZ analysis. 3D Advanced Viewer is under Windows and Advanced 3D Visualizations, and it looks like this. Window, you can input the data by drag and drop or from the tabs. You can just click on the data and edit the data properties if you like. And you can create a chair view. I will display chair view, how we can do the chair view displaying. I have already loaded this seismic data and the horizons. I am editing these color scales for the seismic data to make it better visible. Can easily change the rendering, could be volume rendering or skin rendering. You can easily just change the time slice up and down. It's easily rendering quickly. And the cross line and inline. The data is in LDM format, so it doesn't necessarily show all the data in this view at the higher resolution, but it will increase the resolution based on the zoom you have. Now what I'm doing is creating a chair. I need to set up the sub-volume, which was the red boxes, this one, and also this chair volume. I need to change this volume rendering to the skim mode or the volume rendering mode to be able to see the chair. I change it to the chair, change it to the control to the chair. You see that it's appearing. So what I can do, just edit the edges of the chair, inline, cross line, or in the time slice. For example, I am trying to make it pass through this well, the seismic data, and from the other side as well. I can rotate it and edit that side and try to pass through the other well. In the time slice as well, again, it can be possible. You can easily move the bottom side by grabbing this green handle and moving it up or down. All right. Now this is our chair view, has been composed. We can use it for displays or demonstrations. The other item that you can display is in the volume rendering mode, and it is displaying any tilted slab. So we can just click on the tilted slab sub-volume, and this sub-volume will appear. You can easily rotate using these green handles from any directions, from inline directions, cross-line directions. You can up and down. You can also use these handles to make it bigger or smaller, and you can just drag it and put it in the desired locations. And you can apply desired deep or inclination to the volume to analyze any specific feature in the seismic data or in your property data. All right, so this is showing the displaying. The next step is to display, combine these all information together. For example, wells, sand probability, seismic, horizons. You can compare them together, add them together in one display. Next step is to capture the connected bodies. Connected bodies comes from under the facies classification on LithoSI. You can do the connectivity analysis. It will look like a 3D Advanced Viewer. We have the display data, connectivity analysis, which is importing the volumes, adding the conditions, and calculating the output. And it will display the volumes here. To do that, we run the we have run the LithoSI data, so we have most probable phase volume, and we have probability of oil phases, which is that green phases at the right-hand side. So we have the probability at the right-hand side. We run the connectivity analysis, and I import the LithoSI volume, which is coming from the LithoSI study. I am importing the oil probability and set the criteria for that. I want to see the bodies in the 55 to 100% probability with edge connected and corner connected. Additionally, I can add another volume. I would like to add the most probable lithotype as well. So the most probable lithotype will be also another condition. And I will apply the process. The process will capture the bodies with these conditions, 55 to 100% probability, and within that most probable lithotype, which is oil phases. It will be captured and color coded here. So each color is representing the different connected body. You can view the rotated display, and for example, you can import the wells as well to see how they are behaving with regard to the wells. These results will be written in this green colored volume, and they are also available under the data tree of the HampsonRussell, so you can easily put them in any viewer or export it to be used in the other applications. I'm just putting it in the section view, and you can see the section. I just remove the traces, make them in the color mode. Traces, yeah. So this will be the bodies has been captured. You can change the color scale if you like to display them better if you like. But for the moment, it's looking like orange and green background. And this is the final view of the displayed captured bodies. Next step is to blending red, green, blue, and alpha, the different volumes, and applying maybe alpha. Using alpha, you can just apply transparency. So what I'm doing here is rendering acoustic impedance, VPVS, and shear impedance coming from simultaneous inversion, and also applying gas sand probability volume as transparency controlling. So I am importing the wells just for display. Drag and drop on the view. Then using the RGB blending, then I can assign different volumes to different channels. For example, I'm assigning for red channel, I am assigning this VPVS. For green channel, I am assigning shear impedance, and for blue channel, I am assigning the acoustic impedance. And for alpha is probability of the gas sand phases. And applying that, it will create this render, but it's not optimum because I need to check the data ranges. I can click on that, so that the data ranges can be edited for each channel here. So I'm just editing the channel values here, 1.85 to 1.5. I have flipped this data range to be negative because I want to have the most negative one as the darkest color of each channel. You can also edit this probability volume, which is from 0 to 100%. Now, displaying this rendered volume is easily possible in line, cross line. You can also apply this transparency on the intensity of the color. Just click on the volume and you will see the controls in line, cross line. Okay, easily rendering. You can also apply any specific time slice or domain slice. Right, let's apply this a little bit, increase the Z scale. You can easily just using the general tab on the data view properties, view parameters, you can easily edit it. Now I am going to edit the alpha or opacity for that alpha range, and I'm applying the transparency between 0 to 40% of the probability. So this is my goal, that I want to see the bodies or the areas more than 40% of the probability with the rendered one. So you can easily view at different time slices or at different locations, zoom it. You can also edit turn on and off each channel to see the combination of the other channels together, where the location are, for example, for low impedance, low VPVS, or low impedance, low SI. So you can change them. You can also change the opacity, or rather than 40%, you can make it transparent from 0 to 20%. Other than that, you can apply this volume rendering on the horizon rather than on the time slices or on the cross lines or inline. So let's zoom it at the location and move it to the time slice rendering. So horizon slice rendering. Sorry. So click on the horizon slice. The horizons will be already available under horizons. I can easily just select the horizons, and it will render this RGB blending on any horizons or any offset from the selected horizons. It's good for identifying, for example, any channels close to any horizons. It could be identified by moving up and on, up and down in the volume parallel to the horizon. Next step is displaying the GeoSI results, which are detailed, and they follow stratigraphic gridding, which has been used for GeoSI analysis. You can also, again, apply the transparency to make it at your desired display, at your desired data range. For this case, I am using the 3D advanced volume again, advanced visualization. I have imported the Wells seismic deterministic inversion, which is APPS results. And what I'm going to do, I want to import the geostatistical inversion results. I need to add grid, so geostatistical inversion results will be run on a grid, and they're available under the 3D advanced 3D visualizations. I am selecting VPVS from GeoSI, and I need to edit the data ranges to be the same as the deterministic one. So it is 1.5 to 2.8, same as the deterministic one, and you are able to compare these two together. I'm just turning off the seismic data at the moment, and comparing by zooming at the closer to the location of those, and comparing these two together by turning on and off you see how the details of the geostatistical inversion results, and also how the contrast is higher than the deterministic inversion. Right, next step is to view geostatistical inversion results in for example, in the time slice, cross line, and layer slice. We have layer slice because the grid is being used is composed of the micro layers parallel to the stratigraphy you have defined. So I'm using layers. You can also create slabs. The slabs are thick, for example, inline or cross line or layers. You can select, and you can define how many layers you want to have at each of these slabs. For example, at this specific layer, I want to have 5 layers displayed together. You can also apply the transparency at that data sets, and you can easily see the locations of the interested locations. Then we can compare different, for example, if you have calculated the P10, P50, P90 volumes, you can easily load them into the advanced 3D visualizations and compare them together. So I'm loading all of them. So I have P10, P50, P90, set the ranges to the same range to be able to compare them, and also I need to set the layer location as well. So time range is corrected, and the layer range need to be the same range. Okay, for that volume and for the other volume as well. It should be in the layer display mode, not the full mesh. All right, now setting the locations and the ranges, you are able to compare them by turning on and off these volumes. You can rotate to the desired view and apply transparency as well, if required. At the same, okay. Okay, the fractures coming from the ProAZ analysis, we want to visualize fractures and the fracture uncertainty. At the left-hand side, you see the B-ANI, which is an anisotropic gradient from the Ruger analysis, which is in the ProAZ. ProAZ will also calculate the standard deviation of the B-ANI and the standard deviation of the azimuth and azimuth itself for the fractures. So what we are going to do, we are going to create some display like this and visualize the fractures using those information. And also we can visualize the fracture uncertainty using fracture whiskers or platelets. So to do that, we run this advanced 3D visualizations. I have loaded the wells and the horizons. I want to create the fractures. To create fractures, there is an option there, fracture display section. So I create a fracture, and I need to load the ProAZ session that has been used to calculate this anisotropy B-ANI and azimuth of the anisotropy or fractures. And apply that. It will create at the default locations, but you can change the color, you can change the depth location of that time slice, and you can also apply it on any horizons. I am changing the color at the moment and setting the range to display them properly. You can zoom them at the desired location. This is the data ranges. So to zoom at the specific locations, you can either scroll or just use those options available at the display, which is this one. Yeah. So if you click on any specific location at the display mode, yeah, and click on it another time, it will zoom at that to that location. So you will see that the fractures has been displayed, but it's not very visible. I need to zoom in a little bit more and remove the horizons from the display, maybe. There was one fracture area in this field. I want to move the time slice to that fracture zone, which is under blue top here, to display the fractures properly. Right, so this is just under that top. You see the fractures are scattered. Maybe we need to display them more. I can increase the fracture density by this parameter here and apply that to the display. You will see that it's getting denser and better the definition of the fractures. You can review, zoom, and see at different locations from different angles. The other thing is it was rendered on a time slice. You can render the fractures on any horizon or offset from any horizon. So I'm just applying for horizon number 6 and with 15 offsets, and you can just view the fracture zones, and also you can see the horizons as well. Just display the horizon and see the horizons as well. All right, next step will be creating the uncertainty, displaying the uncertainty of the fractures. Uncertainty will be on the direction of the fractures. So we have this standard deviation for the B and E, and also standard deviation for azimuth. So I'm just selecting the standard deviation of the B and E and the standard deviation of the azimuths, which is coming from the ProAZ study. Then you can these uncertainties could be displayed as two plates with angles with each other, or could be whiskers and fracture in the middle. So fracture platelets in the middle and the whiskers of the uncertainty around it. So at the places where we have whiskers on top of each other, so we have less uncertainty, but when we are deviating from each other, more uncertainty. We can display at a different location, as you see that it's been displayed for whole the area and whole the field using these ProAZ studies. And you can combine different data sets, for example, fractures, seismic, GeoSI data, horizons, wells together in this advanced 3D visualization tool in HampsonRussell. To contact us for more information, you can use cgg.com, GeoSoftware, software support, and regional contacts. And thank you very much for your attention.